Good morning, everyone. So Lisa didn't finish the story. The first seconds aren't what counts. It's the 15 or 20 seconds after that. So thank you very much to the organizers for inviting me to speak here. I'm going to change gears a little bit and talk about, for the first time this week, I believe, about infants and some basic information before I get started. Abbott Nutrition has added lutein, which we get from DSM/Kemin since 2006. So as you can imagine, we're extremely interested in all of the wonderful work that all of you are doing in the adults, because of course our brands range from the premature infant all the way to the adult. So much of the work that you're doing, of course, applies to our Ensure population as well. We don't currently add lutein to Ensure, but we would like to in the future. Meanwhile, through the CNLM, which was referenced with several of the presentations earlier in the week from Martha and from Liz Johnson, and also through University of Georgia from the presentation that Lisa gave. We're also very active and excited in collaborating with such a wonderful group on lutein research. So I'm going to take you into the world of infant formula and discuss with you how we think about the addition of lutein to infant formula. And it sounds like a very simple thing, but it's not, and I'll take you through that journey. So infant formula companies all view human milk as the gold standard. If a compound is not in human milk, we will not add it to infant formula. It's as simple as that. And I purposely underlined and colored the word gold in deference to our topic today, which is lutein. Unfortunately, nowhere on the internet could I find a golden or yellowish color of human milk. So this is probably cow's milk. So just know that I tried to find a color of nice yellow colostrum or nice yellow human milk to show the amount of lutein in both of those fluids. Nowhere on the internet. Also, the philosophy really is that an infant formula company cannot cause harm to an infant. That is a pain worse than death for anyone working in infant formula. And that really is what drives our focus on using human milk as a gold standard. Because philosophically, if a compound which is a nutrient or which has a physiologic role in the infant's body is in human milk, it must be safe to add to infant formula. At the bottom of the slide, the ideal scenario is that we're working on nutrients which naturally occur in human milk. So I've put a check mark because that's true for lutein and zeaxanthin. Has a clear role in the baby's body. Check mark for lutein and zeaxanthin. We spent the whole week talking about the eye, and of course, the eye is a crucial organ to the infant. Much of the learning occurs through vision very early. And as we know, lutein and zeaxanthin deposit in the macula. And also from my perspective, and this is not universal in the infant formula world, the more evidence there is for the human body having specific biochemistry machinery for absorbing and transporting a nutrient to specific sites of action, the more confident you are in adding that particular compound or nutrient to your infant formula. So there are two general philosophies that infant formula companies use to add a new nutrient to infant formula, and also with which to select the concentration that's used. The first is to pretend that a nutrient in infant formula, added to infant formula, behaves exactly as that same nutrient in breast milk. If you're a disciple of that philosophy, then you will follow what we term a compositional strategy, which is to add exactly the same amount of that same nutrient to your infant formula as you see in breast milk. There's a second philosophy which builds on that and emulates then the functional attributes of that nutrient or compound in breast milk. That is a strategy that we use at Abbott Nutrition for the simple reason that, that almost across the board, nutrients have to be fortified at higher levels in infant formula than in comparison to the levels that you see in human milk. And there are a number of reasons for that. One very simple reason is that infant formulas have to be commercially sterile and therefore are cooked to an extreme amount. Also, the container spends up to 2 years on the shelf before consumed, so that over time the concentrations of the nutrient in question change. And there's also extensive evidence that nutrients added to infant formula are not as bioavailable as those in human milk, probably because of the complex structures that we see in human milk. But it's far more complicated than that. Breast milk is a biologic fluid and therefore is a moving target. So human milk represents this extraordinarily complex, in some cases, relationship between maintaining the mother, but ensuring that the infant succeeds in its growth, and that leads to a great deal of variability over time. If you look at human milk composition carefully, virtually every nutrient in breast milk changes with the stage of lactation. And in general, the concentrations of nutrients decline from colostrum to mature human milk. But on top of that, within a single breast milk feeding, there are differences in composition, as shown by the two flasks in the picture, where the foremilk or first milk to come out during the feeding tends to be more dilute than that which comes out at the end of the feeding, which tends to be higher in fat and higher in fat-soluble compounds, which of course include lutein. In addition, in deference to the country that we're in, mom's metabolic status, as opposed to mom in the States, mom's metabolic status can also have a profound effect on breast milk composition. And finally, as in the case of lutein and zeaxanthin, if the nutrient in question is not made by animals, then mom must acquire that nutrient through diet. Perfect examples, of course, are lutein and zeaxanthin, but also all of the essential nutrients, including vitamin A, vitamin E, and on down the list. So when you put all of this variability together, the question of matching both composition and function becomes really complicated because the target is a moving target. So the question is, which one of the targets do you shoot at? And how do you then create convergence between whichever target you choose and the amount of a given nutrient that you put in infant formula, given my earlier statement about the fact that the container's on the shelf for 2 years, up to 2 years, and also changes chemically due to the processing that the infant formula goes through. So lutein and zeaxanthin are widely found in human milk and are accepted as breast milk nutrients. And I know there's some hardcore nutritionists in the audience, so I say nutrient with quotation marks around it, because as we've discussed earlier in the week, there is no deficiency syndrome. So at the very least, lutein and zeaxanthin are not essential, are not nutrients in the classical sense. The lutein and zeaxanthin in breast milk, I'm sure it's not an extension for all of you to realize that the lutein and zeaxanthin in breast milk was acquired through the diet by the mom at some point in time. There could be adipose depots or perhaps other depots, but nonetheless, those depots were derived from diet. Lutein and zeaxanthin are currently added by some infant formula manufacturers, and in fact there are two, and I'll refer to some of the work later in my talk. Wyeth Nutritionals, which now belongs to Nestle, and Abbott Nutrition. But more broad addition will not occur until lutein and zeaxanthin are considered to be semi-essential nutrients, or conditionally essential nutrients. And so to boil all of that down, the Abbott philosophy is to first begin with composition, but of course we don't stop with composition, we move toward function as well. So here are some data that were published by Canfield et al. Years ago, and we have one of the authors, in case you have questions, we have one of the authors on that paper in the audience, and that's Martha Nuringer. And the bottom line here is, in addition to many of the complicating factors I've already listed, in this study, if you look at mean lutein plus zeaxanthin, because the two compounds were not separated in this particular paper, analytical technology has come a long way since this paper. If you look across the country, the average levels in breast milk vary dramatically, so that in the Western nations like US, UK, Australia, Canada, and even places like the Philippines, the breast milk on average contains far lower levels of lutein and zeaxanthin than those seen in Japan and China. And it's very clear, given the fact that the lutein and zeaxanthin must be derived from diet, that these differences are driven by dietary differences, probably related to traditional lactation diets. An additional point, however, about breast milk is that because the dietary component is crucial in the case of lutein and zeaxanthin, the means and the standard errors, or standard error of the means in this particular graph, in my opinion, are extremely misleading, because if I didn't have the raw data, but if you drew a scatter graph for each of these bars, the scatter is extremely wide, and I'll show some of those data from Abbott later on, and all of these populations will overlap, but those with higher means will have skew toward the higher ends, toward the higher end. So there's even an additional question here, since Abbott Nutrition is a global company and we supply infant formula across the world, is now that we have cultural differences, which one is the appropriate target? It's for an infant formula manufacturer, it's absolutely impossible to manufacture different formulas for each one of these companies. It's just not feasible. So we have to choose one target, so how do we go about that? There's one additional set of data that I'd like to share before I get to the crux of the question. On this graph, there are now infant plasma lutein data from both Abbott Nutrition in the blue bars and Wyeth Nutrition in the green bars. These are separate studies, and it's amazing how tightly these two studies align. So let me walk you from right to left, from left to right, sorry. So the first group of bars are show the level of lutein in the plasma of breastfed infants, where these are US breastfed infants. And the two numbers below the x-axis show the average level of lutein in the breast milk cohorts that were studied, expressed as microgram per liter. So in the breastfed infants, the average level was about 6 micrograms per DL in the infant plasma. And the numbers above the bars show the number of infants studied. If we then move from right to left, the bars show independent data from the Abbott and Wyeth nutritional studies, and the numbers below the axis show the amount of lutein added to the infant formulas expressed as micrograms per liter. And so you can see the key points are that when the same level, when the level of lutein in the infant formula matches the average level in breast milk in the breast milk samples, the plasma level in the infant comes nowhere near the level seen in the breastfed infants. Then if you move further to the right and roughly double the level of lutein added to the infant formula, the resulting plasma level in the infants remains lower than that seen in the breastfed infants. If you continue to the right and add levels of lutein 117-ish to 120-ish micrograms per liter or higher, now the plasma levels vastly exceed those seen in the U.S. breastfed infant. So you can imagine for a U.S.-based company the amount of consternation that drove, because we really should not be in the position of being in the marketplace supplementing our infant formula at lutein levels that drive higher plasma level than the breast milk cohorts for the same country. So, but the key point here is that Canfield's work that I showed on the previous slide clearly showed that the level of lutein in the breast milk of U.S. Women is also dramatically lower than that seen in China and Japan. So the question that's really begged here is whether the levels of plasma that are being driven by the higher levels of lutein fortification in the formula actually match those match the plasma level in the breastfed infants from countries where the women consume far more lutein and zeaxanthin. Before we did this study I'm going to present to you, many people had studied the level of lutein and zeaxanthin in the breast milk in those countries, but no one had measured the resulting plasma level. So really that really represented the compositional matter for the addition of lutein and zeaxanthin to infant formula, but did not close the gap to the best available functional measure. So to finish off the baseline, the background before we get to the clinical trial, it's very clear if you think through the previous slide that when we add the same amount of lutein to infant formula in order to match the composition in breast milk, we don't get the same plasma levels. If I show you that to you graphically, this is the Wyeth work. The Abbott work shows exactly the same thing, lays almost right on top. The slope between lutein concentration in the diet and the resulting plasma level in the infants, the slope is clearly different, which means then we clearly have to add more to infant formula. The really hard question is, in these populations where the breastfed infant has access to breast milk, which is far higher in lutein and zeaxanthin, at this point it was an unknown whether those plasma levels would plateau or whether they would continue to increase. And that, of course, with respect to infant formula and the quote-unquote essentiality, sorry, John, of lutein and zeaxanthin to the infant, that's a really important question because you might draw a different conclusion if plasma levels plateau in response to increasing breast milk concentrations, as opposed to observing a linear relationship where as breast milk levels increase, infant plasma levels increase. So we wanted to do a clinical trial, and we ended up, because Lisa indicated yesterday that every clinical trial must have an acronym, I named this trial the CLUCS study. I was doing this slide really late last night, so my imagination was waning. I just wanted to get the slides done. But the CLUCS study stands for Chinese Lutein Colostrum Study. It's actually not a study of colostrum, it's a study of breast milk, but B didn't work in the acronym. So in this study, we worked at Abbott Nutrition with our colleagues in both Singapore and China to pull off this study. And we ran a human milk a breastfeeding mother, breastfeeding baby dyad study. And we did that study in coastal China because the previous study showing that breast milk lutein levels are extremely high in China was done in coastal China. And so we did this study in Shanghai, where Abbott happens to have a technical office. And we wanted to ask the question as to whether infant plasma concentrations of lutein and zeaxanthin continue to climb as breast milk levels continue to climb. Because you can imagine from the infant formula perspective, if the answer to that is yes, then it's even possible that these higher concentrations that we tested clinically previously might not be high enough. Because we've already heard extensive conversation about the importance of macular pigment. We've heard Martha indicate that the human infant and human infant and primate infant are both born with very little macular pigment. So now if you imagine, on the one hand, infant formulas that are not supplemented, what's happening with the infant, with the macular pigment in those infants? And on the other hand, if you imagine a supplemented formula, you want to optimize the deposition of that pigment. In order to do that, you need to make sure that you have the right concentration. So if it turns out that breast milk, that the resulting plasma levels in an infant consuming breast milk that's very rich in lutein and zeaxanthin continue to climb, then that would tell me that the concentration in infant formula should be accordingly high. So we did this trial in Shanghai, China, and we recruited 56 breastfeeding infant dyads, and the mothers were all healthy. And we went one step further and said and decided to not only recruit Chinese breastfeeding women who had the expected diet in China, which is rich in green leafies and eggs and fruits, but we instead said, we're going to change the model a little bit here, and we're going to recruit the upper 1/3 of that population. Because we expected that the upper 1/3 of that population is actually one of the few human groups on the face of the earth who are actually following guidelines for consumption of green leafies, fruits, and in the case of lutein and zeaxanthin, eggs. It turned out that this group was actually not that difficult to enroll. One of the things I've learned, however, is that sometimes language barriers can be difficult, and I cannot present to you how many dyads we turned away by using that more stringent requirement. I'm told by the site that it was not very many mothers. So this is roughly representative of a common upper 1/3 breastfeeding Chinese dyad. The infants were between 6 and 16 months or weeks of age during this study. We routinely choose this age when we do infant formula trials because we want to study them before the introduction of solid foods in order to avoid potential contamination of our question with foods containing whatever compound we're interested in. And we used standard methodology for detection of lutein and zeaxanthin. We collected dietary records during prior to collecting breast milk. We collected 2 breast milk samples and also maternal and infant plasma. And we were actually successful in collecting infant plasma from every single infant. And let me tell you, having done a lot of infant trials, that's incredible performance. I was really surprised by that. Simply to show you in the red bold, the consumption of dark green leafy vegetables, fruits and eggs was extremely high in these women. Their daily intake averaged about 3.3 milligrams of lutein and zeaxanthin per day. But you can see the range was huge. Screening using dietary records don't tell the entire story. So bottom line here, I'm going to go through this slide very quickly and just focus your attention on the red bold and also the human milk concentrations. Bottom line here is that, in fact, we did find that the concentrations of lutein and zeaxanthin were approximately 3 times higher than those that we've previously seen in the US, and the infant plasma concentrations followed suit. Although the correlation is not particularly compelling to me, I believe my eyes more than statistics. This relationship did turn out to be linear, and the red box shows our previous experience in US breastfed infants, just to show that the Chinese population actually overlapped with the US population. Although the US population is in the red box covers all infants but one. There was one outlier, but the Chinese population is skewed far to the higher range. And I've simplified these results by just showing a box plot. The box shows you range, the bar is mean, and the 2 dots above the two bars are just 2 infants that looked different. And the bottom line here is that the plasma levels in the Chinese infants do overlap with those in the US, but are skewed far higher, and that all the concentrations previously studied by both Wyeth and Abbott fall within that range, and the means are very close to the Chinese range, to the mean range, meaning that these concentrations are falling within the range seen in breastfed infants fed milk very rich in lutein and zeaxanthin. So the future question I would leave you with is, what gives with this difference in bioavailability? That seems to me to be a very important question. We've seen some suggestion on eggs that the lipids present in eggs might play a story. Maybe the same is true in infant formula. So I'll take questions if there's any time.
Time for 1 or 2.
2 questions. One, did you do an analysis for mesozeaxanthin? And 2, it's an interesting graph that you showed about the distribution where like Japan and China, which tend to have PCV, have higher levels in the milk versus the countries like the UK, Australia, and the United States, which have lower levels, who have a different type of wet AMD. In particular, they have the classic lesion versus the PCV that you tend to see in Japan. And there was a question by Dr. Howard earlier on asking if there was a dietary difference.
There clearly is.
That clearly is.
Yeah, there clearly is. And no, we have not done any analysis for mesozeaxanthin. I've had several interesting discussions about that during the week, and we'll have a look.
Julie, and we'll cut it there.
Okay, thank you. See, I think what you mentioned right at the end could be key. So, what is the lipid lutein complex in human milk, and how does that differ between breast milk in the U.S., for example, compared to China? The levels of lutein that you showed in the diet of the Chinese sample that you had weren't that much higher than U.S. So I'm wondering, whether their diet, or probably more likely their metabolic state with regard to, say, HDLs, might permit the delivery of lutein to breast milk in a more efficient way.
Yeah, I had the same thought. The lipid profile and lipid composition is clearly very different between infant formula and breast milk, because breast milk has a very complex structure which we cannot replicate in a manufactured product. But beyond that, the same thing hit me. Although the skew in intakes were very high. I mean, the intake went up to 19 milligrams per day. But the same thing did hit me. There must be something more to the story in these populations. I for one, don't know what it is.
Why can't infant formulas change the lipid composition, the lutein, the way lutein's delivered? I don't really know.
We can change lipid composition, but we cannot duplicate the 3-dimensional arrangement of lipids in breast milk, because breast milk contains something called the milk fat globular membrane, which is a 3-dimensional structure which includes complex lipids, proteins, when we make infant formula, we stir it up and we abuse it and we cook it, and there's just no way to keep a structure like that in place.
Thanks, Matt.
Yeah, thank you.